All right, let's take a look at question 22. In question 22, we're being assessed on how to solve systems of equations by substitution. Okay, the question reads, it says, using the substitution method, Vito is solving the following system of equations algebraically. So y plus 3x equals -4, 2x minus 3y equals -21. The question is, which equivalent equation could Vito use? Alright, so when you're solving systems of equations by substitution, there are 3 steps you want to keep in mind. Okay, so let's write steps for solving. Steps for solving systems by substitution. Okay, alright, so first thing you want to do is you want to isolate. Alright, you want to isolate a variable from one equation. Okay, isolate, and the next thing you want to do is you want to substitute what you isolated in the next equation. Substitute, and then 3, you solve. This solve process is 2 parts. You solve for one variable and then you substitute it back into the other and solve for the other one. Okay, so just think ISS to solve systems by substitution. Isolate, substitute, solve. Alright, so as we are executing these steps, we're going to see what the correct answer is. So let's do the first step, which is to isolate. Okay, so step 1, isolate. Now, for the isolation step, we're going to take a look at all the variables here. There are 4 of them. And then we ask ourselves, which is the easiest to get by itself? In most cases, the one that has a coefficient of 1 is normally the fastest to be isolated. Okay, when you have a sign or an integer, a coefficient that's not 1, you have to divide. So that's a division step. But when you have a coefficient of 1, that variable is the easiest because you do not have a division step associated with it. So if you look at y, this y in the first equation, let's label it. So let's call this 1 and call this 2. So in equation 1, y has a coefficient of 1. This is the variable that you want to isolate. Why is that the variable that you want to isolate? Because it's the one that can be isolated with the fewest number of steps. Remember, the shorter you can make your work, the less likely you are to make mistakes, and you save time too. Alright, so that's the strategy we're going to use here, and that's the same strategy that Vito used. So we're starting from equation 1. What do we have? From equation 1, we have y plus 3x equals -4. Our goal is to isolate y, get y by itself. So to isolate y, we will subtract 3x from both sides of the equation, and that yields y equals -3x minus 4. This is equation 3. Ladies and gentlemen, we have achieved the isolation step. The isolation step involves getting a variable isolated all by itself without any coefficients. Now step 2 is to substitute. Okay, now we need to remember where 3 came from. 3 came from 1, so we're going to substitute 3 into 2. We can't substitute it back into where it came from. You have a circular definition. You're not gonna get anywhere with that. Okay, so what are we about to do? For the substitution step, step number 2, which is to substitute, this is what you are going to do. We are going to substitute this value, -3x minus 4, for y in the other equation, namely 2. Okay, alright, so let's go ahead and write down equation 2. What is equation 2? Equation 2 is 2x minus 3y equals -21. Okay, that's equation 2. Now what we're going to do is substitute. Okay, so let's call this equation 2. we're going to substitute this into equation 2. So to do that, what we're going to do is take 3x minus 4 and plug it into the y spot in equation 2. So what results after that? When we execute that step, we're going to have 2x minus 3. Instead of y, we're going to replace it with the y value that we got from equation 1, which is negative 3x minus 4 equals negative 21. Let's freeze right there, because it looks like we have a format that's similar to what we have here, okay? So upon the substitution step before simplification and solving, let's see if we have a match. 2x minus 3 times the quantity negative 3x minus 4 equals negative 21. Ladies and gentlemen, the correct answer, or the equivalent equation that can be used to solve this equation, is option number 3. Okay?